So I mentioned a little bit in the previous part about reaction rates and how the height of the energy barrier is going to determine the rate. The higher the energy you have to overcome, the slower the rate is going to be for the reaction. And so there are some things that can affect reaction rate. One thing that can affect the reaction rate is to increase the concentration of the reactants. If I increase the moles or molecules or atoms of reactant, then I'm going to be able to increase the number of collisions because I have more of those things that can bounce off each other and off the sides of the containers and such as that. So the more collisions I have, the more likely I am to have a reaction. Increasing the temperature also increases the reaction rate because I can increase the average kinetic energy of the molecules. If you've ever walked on a hot pavement and you didn't have shoes on, you're not going to walk slow over that, okay? I'm talking about Florida hot, sand hot. You're going to rush and try to hurry up. And so in the same kind of way, heat or increase in temperature gets those molecules going faster and bouncing faster and moving and hitting each other, and therefore that's going to also increase those collisions and increase the reaction rate. Something else that can affect the reaction rate is the presence of a catalyst. And a catalyst is a substance that speeds up the rate of the reaction, but the catalyst recovers unchanged in the reaction, and it's not part of the product. So basically, the catalyst helps the reaction speed up, and it's regenerated back into its original form so it can then catalyze another reaction. And so the way we say this in chemistry language is that catalysts accelerate the reaction by lowering the activation energy without changing the change in enthalpy. All right? And so in the case of a catalyst, what we have is this is an endothermic reaction because I'm starting out down here with reactants and my products are going to end up here at a higher energy. This in blue is the path that it takes without a catalyst. And so basically it's this much energy I have to overcome from here to here. The presence of a catalyst is going to lower that activation energy where I only have to get to this point, and by lowering that activation energy it speeds up the reaction because I don't have to overcome as high an energy barrier to get to that transition area where that reaction will then occur. So the uncatalyzed reaction, which has a higher activation energy, is slower. The catalyzed reaction, where the activation energy has been lowered, is faster. But notice it does not affect the delta H of the two reactions, which is here. That delta H is going to be the same. It is not affected. So in the human body, we do have what are called biological catalysts, and the term for those is enzymes. And you've probably heard about enzymes, and enzymes are primarily made of protein molecules, and so they have this three-dimensional shape which makes them active or functional. And if they don't have the correct three-dimensional shape, then they don't work. And so in this three-dimensional shape there is something called an active site, and that active site is going to bind the reactant or reactants, which are then going to undergo a reaction at a faster rate. So, for example, lactase is the enzyme that is going to convert sugar lactose, which is the sugar in milk, into two sugars, glucose and galactose. And if you are one of the unlucky people who do not have enough lactase, then you're going to have stomach aches when you eat dairy, and because you can't digest the lactose. and so we call that lactose intolerant. And so that lack of that enzyme or enough of that enzyme to convert the lactose then is not going to allow you to convert it into the form that you need, and so it's going to cause intestinal problems. So when you look at this in like 3 dimensions, this enzyme, okay, this whole thing is the enzyme. It's usually a globular protein. You can see why we call them that, right? Okay, so there's an active site here. Okay, so this portion right here, this is an active site. And the way it speeds up the reaction is you take a molecule that fits in there, okay, and so it's attracted to some things along this active site. And so it sits there, and so everything is close together, and so since it's closer together and stopped from bouncing all around, then it's a lot easier to have that reaction take place. And so in this case, you're splitting the galactose and the glucose molecule so that you can digest that and use that glucose for fuel. If you weren't able to do this, that lactose would be so slow at being converted that it just kind of ties everything up in your intestines and gives you a bellyache. So enzymes are your friend.